Welcome back to Intermediate Algebra with Jeff Anderson. We are still in Lesson 1, which is Introduction to Algebraic Equations. Here we're in Video 3, which is really going to focus on special operations. If you remember from the last two videos, we did a quick review of the most famous of all operations. We kind of looked at these as coming in pairs. We saw that addition and subtraction are going to be inverses of each other. They undo each other. And then we also saw the same thing for the multiplication and division pair. In this third video, we're going to start taking a look at special operations. The first special operation that we're going to study is something called the absolute vodka operation. Absolute value operation. Sometimes when I'm taking absolute values, I feel like some absolute vodka, so that's kind of nice. When we look at absolute values, we're going to think about this as measuring the distance from zero of a number. So in an example of this, if I say the absolute value of -5, this is going to be equal to 5. The reason that we conclude such an output for this operation is if we look at the number 0 and then we go 5 units to the left of 0, here we see the number 5, and then what we say is if we were to actually travel this length, we would have to go 1, 2, 3, 4, 5 units. In other words, -5 is 5 units away from 0. One quick note here. When we say the absolute value of -5, we're referring to the entire expression. I want to call out the anatomy of the absolute value expression. So if I look at what we're going to say, the absolute value of x, these are going to be called the absolute value bars. Just like there could be something called an absolute vodka bar, these are going to be absolute value bars. So when I drop these little babies on, they're just straight lines on either side. And then this is going to be what we call the input to the absolute value. So the thing on the inside is called the input to the absolute value. This whole thing is called the absolute value of x, and it measures the distance from 0 as seen on a number line. In absolute values, negatives turn to positives, positives get left alone, and the absolute value of 0 is, of course, 0. Let's take a look at our next operation, which is going to be the square power of a number. So a great example of this would be, let's say that we had 5 squared. The way that we read this is the number 5 squared. Another way to read this would be 5 to the second power. Either of those work. And when we're thinking about the square of a number, we're going to count 2 multiplications. So here, when I say 5 squared, what I really mean is 5 times 5. There are 2 multiplications with the number 5. And of course, 5 times 5, we're going to conclude is 25. I want to talk now about what we're going to call the anatomy of a square power. So if I look at what we're going to say, maybe we'll call it x squared. The thing on the bottom there, we're going to call it the base. The thing on the top there, we're going to call it the power. And when we say x squared, what we really mean is x times x. I'm going to multiply the base by itself the number of times indicated in the power. So multiply the base the number of times in the power, and that's what we mean by x squared, or x to the second power. That's another way to say that.